of these functions. Further and last, we will also discuss some future scope for the research in this area. So first of all, everyone having a question in their mind that what is incomplete function or what are the incomplete function? Because there are so many types of functions which are called as special functions. I think during these 3 days, you have already discussed about the definitions of special functions. That means they are functions which are solutions of some special type of differential equations. Okay. So along with those different special functions, what are the incomplete functions? So a simple definition for those functions are that assume a function can be decomposed in two functions with almost identical properties of the original one, and also the combination of these two functions may recover the original function. Then these two functions are known as incomplete functions. This is a simple basic definition of the incomplete function. That means if a function can be decomposed in two functions in which both the functions, which are the decomposition of the original one, follows the similar type of identities of the original function, and again by adding those two functions will recover the original function, they are known as incomplete function or family of incomplete function. There are so many directions for the incompleteness of the functions. So we are starting with the gamma function only, because dealing with the special functions, you are well familiar with the gamma function. So if we define the gamma function, it is an improper integral from 0 to infinite t power s minus 1 e to the power minus t dt. So this is the gamma function, which is well known to all of us. So the incomplete functions associated with this improper integral are defined by Chaudhary and Jubair in 2001, and they have given two functions which are decomposition of this particular function. They are known as incomplete gamma function. This is the lower category incomplete gamma function, which is known as lower gamma function, lower incomplete gamma function, and this is the upper incomplete gamma function. So here you can see the limit of integration is for this function is 0 to x, and the same integrand having limit from x to infinite. So if I add both the functions, it will again recover the original gamma function. Okay, so we simply say this gamma function is decomposed in two functions, that is lower gamma function and upper gamma function, and these two functions are known as incomplete gamma function. Okay, so every time we will be getting two category of functions, one of the type lower and another as a upper gamma function. So why there is a need of these incomplete function? So as per literature, there are so many applications available from these incomplete gamma function, particularly evaluation of indefinite and definite integrals. They have shown number of applications in this area. Applications of probability distributions, concept of incomplete probability distribution and normal distributions. There are so many applications of these incomplete functions with these statistical distributions. They also have some applications in heat conduction and associated problems, because the main generation of this invention of these incomplete functions is created due to this particular heat conduct equation. There are so many areas in which the special functions are unable to resolve the problems associated to the physical problem. So in that case, they have used the incomplete functions and they are successful. Again, we also use those functions to define extended incomplete function. We can also extend those functions or get more generalized version of the functions. So if we consider the category of special functions, we all are familiar, or even in last 2 days, you have learned about the number of types of special functions. The Gauss hypergeometric function is the immediate generalization of the gamma function. After gamma function, you got the Gauss hypergeometric function, or we can say this is the first special function which we are taking as a category of a special function. Its generalization is given as generalized hypergeometric function. And then we also have Fox right function, Major's G function, Fox H function. After H function, there are two categories of the generalization. One category involves the I function defined by the Saxena, VP Saxena, and another generalization is LF function. In another direction, we have the function defined as H bar, I bar, and then I function. Okay, so these are the two generalization of this Fox H function. However, there are so many directions for the generalization. Nowadays, PQ generalization or K generalization, there are any other more than dimensions available for the generalization of special functions. I am here considering only the initial one. Initially, there are only two categories of generalizations like this. So these functions are well known and defined by the researchers. You can see the references on this particular slide. Now, if incomplete functions are started from the gamma function, then obviously their generalization will be available with these functions also. Okay, so all the functions, they have been decomposed and obtained their incomplete function. So let me start with the study, or we can say the review of this particular part. The incomplete Pocamber symbol, which is defined by these two notation, are given by these two relations. These two relation includes the lower and upper gamma functions, or we can say lower and upper incomplete gamma functions. So these are the Pocamber symbol involving incomplete gamma functions. If we use these particular Pocamber symbol to define the generalized hypergeometric function, we will be getting the incomplete hypergeometric function. So in Srivastava et al. Defined this particular term as a incomplete hypergeometric function. So you can see this particular relation 7 provides you the definition of incomplete generalized hypergeometric function, which is denoted as P small gamma q and P capital gamma q, because every time you will be getting two functions associated with the incomplete function. Okay, so this is the lower generalized hypergeometric incomplete function. Similarly, this is the definition of the upper hypergeometric incomplete function. You can see only one particular parameter is replaced by the incomplete Pocamber symbol. Every other parameter is same, which are available in the normal hypergeometric function. Only the single parameter available in the numerator is replaced with the upper incomplete type function. It will be upper incomplete generalized hypergeometric function. If we replace it by the lower category type, it will be the lower incomplete hypergeometric function. So these are the function and having this particular decomposition formula. You can see if we add this lower generalized hypergeometric function with the upper incomplete hypergeometric function, you will be getting this generalized hypergeometric function, because this particular formula must require for the decomposition. Okay. Again, as a extension of this particular function, Srivastava and Parmar also introduced the Fox right function in terms of incomplete category. So here you can see again there are two functions. Hello? Are you hearing me?
Perfect.
Okay. So again, you can see there are two right function, Fox right functions, one of the type lower category and another is of the upper category. Okay, and these are the two definitions available with that. So always you can see one single parameter will be replaced by the incomplete gamma function only. The change is this one only, but these are having number of applications. The change is very small, but the application part is very strong. Again, these are some convergence conditions available with the right function. They are also given in those paper, and obviously those two functions must follow this particular decomposition formula. Okay. Very recently, Srivastava and Parmar also introduced this particular slide indicating you the normalized incomplete hypergeometric function. Okay, how we are making normalized? We simply add or multiply or divide some gamma function to make a simpler presentation of this right hypergeometric function. So these are the two another representation of the right hypergeometric function and called as normalized incomplete right hypergeometric function. Okay. Okay. Now recently Srivastava, Parmar and Saxena defined this particular incomplete hypergeometric function for the Fox right function, Fox H function. Here you can see these are the two representation. One is associated with the lower gamma function and another is with the upper gamma function. So if you remember the definition of Fox H function, we are indicating H, Mn, Pq. So instead of H, we can write it as a small gamma Mn, Pq and capital gamma Mn, Pq, which indicates you the incomplete H function. So these are the two incomplete H function, one of the type lower and another of the type upper. Here you can see these are the some notations and this particular gamma is replaced with the incomplete type function only. Only this particular change has been made to create the category of functions. Here again you can see this is the upper incomplete type gamma function. So this particular function will be called incomplete H function of upper type. Now, so obviously these two functions also follows the decomposition formula. Okay. Now, if you remember, I have mentioned you the two directions of the spatial functions. One direction after the H function, one direction goes to the I function and then LF function, and another direction will be H bar function, I bar function, and then I function. So recently, Bansal and Kumar also introduced the incomplete I function, which is an extension of the I function provided by the Saxena, and also provided the recently incomplete ILF function is also defined. So we are not considering that particular direction. We will be considering the another one. So we will be considering H bar, I bar, and then I function. Okay. So recently, Jangid and myself introduced the particular family of incomplete I functions. Obviously, they are two category of functions. One is of lower type and another is of upper type. Okay. So these are the two functions defined by 19 and 21. So here you can see this is the incomplete I function of lower type and another is of upper type. This is of upper type. Okay. And these two functions are defined by these relations, that is 20 and 22. Here we have made this particular change. So if we compare this particular definition with the definition of the I function, which is provided by A.K. Rathi. So this is an extension of the definition provided by the A.K. Rathi. So we simply say these are the decomposition formulas of the I function provided by A.K. Rathi. So here you can see we have changed this particular definition. So using the incomplete type of gamma function, we will be getting the another result. So again, there are some special cases available with this incomplete I function. This particular function is the very much generalized version of the spatial functions. However, there are so many types of generalizations available in the literature. But in one category, this particular function is the generalized category of the spatial function. So if we put some special parameters or particular values to the parameter, you will be getting the number of special functions as a special case of this particular function. So you can see if I put x equal to 0. So if we put x equal to 0, the incompleteness will be removed. You can see in the incomplete gamma function, the limits are 0 to x and x to infinite. If I put x equal to 0, that means the first integral vanishes and second integral will continue from 0 to infinite. So it will be a gamma function. So if I put x equal to 0, that means the incompleteness of the function is removed and it will convert it into the original one. So there are two ways for getting the original function, or we can say to recover the original function, there are two ways. First, we can use the decomposition formula, or another we can put x equal to 0. So if we put x equal to 0, that will be yield to the familiar I function provided by Rathi. So this is the reference available for the function. And further, if we put b1, b2, bn equal to 1 in this function, it will convert it into the I function, or we can say the function parallel to the I function. So we can call it as a incomplete I function. So again, there are two incomplete I function, one of the type lower category and another is of the upper category. Okay, and obviously they will be following the decomposition formula. So here again you can see there are some special cases available with that. If we put x equal to 0, already mentioned that it will convert it into the I function provided by Rathi. If we put a1, a2, ap equal to 1, b1, b2, bn equal to 1, it will be converted into an incomplete h function because it is a immediate generalization of this one. Further, if we put b1, b2, bn equal to 1, it will convert it into an incomplete I bar function. And these are few more special cases of this function. So we can say this particular incomplete I function is a very much generalized version of the special functions. Now we particularly discuss about some basic properties of these two functions. However, I have not considered the proof of those results due to the lack of time. I'm simply giving the main result of the associated with these two functions. So if we remember, there are so many work has been done with the Fox H function, I function, I bar function, H bar function. There are number of applications and work reported in the literature. So if we follow the literature, there will be a number of scope for getting the result associated with these two incomplete function. However, we have considered only few of them. So here you can see incomplete function follows these two particular property. So here you can see these are the simple recurrence relation associated with the incomplete function. And how we can prove this particular result, maybe 25 or 26, can be obtained by simply rearranging the parameters only. If we recall the definition of incomplete I function and rearrange the parameter, you easily get these results. And these are the recurrence relation for the I function. So this is the first theorem which is associated with the lower incomplete I function. Similarly, this particular theorem indicating the same type of recurrence relation with the upper incomplete hypergeometric function. It is very interesting that every property having the same line of proof for lower as well as upper, because they are the decomposed of the original one, and even we can say they are following the similar procedure for getting the proof of result which are available with the original function. Only due to the specific applications we are going to discuss these functions separately. Okay, so this is a simple recurrence relation. Another you can see, this is another recurrence relation available for this lower type of function. These are few more recurrence relations available with the lower type of incomplete integral. And even we can say there is a lot of scope available to get the such type of recurrence relation in this function, because they are still unavailable with us. So we can create a similar type of recurrence relation for these functions. I have reported only few of them. Further, these recurrence relations are associated with the upper incomplete I function. Okay, now you can see this is a simple differentiation formula, kth order differentiation formula available for the lower incomplete I function, and it is parallel to the formula available for the original I function provided by the Rathi cell. Similarly, the same type of differentiation formula is available for the upper incomplete I function. Normally we are calling it as a family of I function. Okay, so which includes lower as well as upper function. Further, now in the next category, we are going to prove some generating functions associated with the incomplete I functions. So if you remember, these type of generating functions are already available in the literature, and similar type of generating functions are available for Gauss hypergeometric function, Fox H function, Major G function, and many other functions. Here we have presented the same type of generating function for incomplete I function of upper as well as lower category. I have skipped the proof of these two particular results for the sake of time. Similarly, you can see this is another variant of the result for the lower category of functions. Okay. Again, if we define a function, we have also proved some another type of generating functions. If we consider this particular function as a summation of the incomplete I function, then we can easily prove this particular generating function. The result presented here are all published in the reputed journals. Okay, so if you need, I can provide you the PPT as well as the copy of the papers. No problem in that. So this is a simple generating function available with the upper incomplete I function. Similarly, now we come to the integral transforms of the incomplete function. In the category of properties of incomplete I function, we will considering this particular part. So if we recall the Laplace transform of a given function f of z, it is provided by this improper integral. And then if we apply this Laplace transform definition to the incomplete function, maybe of lower category or upper category, you will be getting the image formula for this function under the Laplace transform. So this is the Laplace transform of your incomplete I function and provided by this one. Similarly, if we apply the same concept of Laplace transform to upper type of incomplete I function, you will be getting this particular result. Okay, I have not considered the proof of those results. Further, if I consider the Mellin transform, then you can see the Mellin transform of a function f of z is given by this particular improper integral, and every I function, h function, they all are expressible in terms of Mellin-Barnes type integral. So using those particular concept, we can easily get the Mellin transform of those incomplete functions. So if I apply the Mellin transform to incomplete I function, it will be provided like this. So here you can see the integral will be removed, and only we use the this particular proof is very simple, and we simply using Mellin-Barnes type representation of the I function, and then comparing the result, you will be getting your Mellin transform directly. Similarly, for upper type of integral, upper type of incomplete I function, the result is this one. These are the some convergence conditions which are available with those results. Okay. Further, if we consider the Henkel transform, then obviously the Henkel transform of function f of z is given by this integral. And if we apply this definition to incomplete functions, maybe of lower as well as of upper type, you will be getting the image formula of that function under this Henkel transform. So these are the results may be provided by equation 47 and 48. There is a lot of scope for getting the results in this direction. Okay, I will discuss in last. Okay, further you can see the Euler beta transform. So it is very familiar with the persons working in this special functions. So if we apply this beta transform to our function that is incomplete I function, you will be getting the immediate result associated with that. So beta transform of this incomplete function will be provided by this one. Again, For upper category type of incomplete I function, the result is given by equation 51. Okay. Now in another part, we will be going to discuss some integrals associated with these two functions. That is family of function, we can say. So there are so many integrals available in the literature which are going to used frequently the persons working in the area of special functions. And I have considered few of them. So if we follow the Oberhettinger, they have provided this particular formula. So the basic concept is simple, that we use this particular integration and get the results, or we can say we can generalize those integral involving the incomplete I functions. So here you can see this is a well-known result available in the literature. And again, another formula which is going to use is this one. So these integrals are already available in the literature. So along with these integrand, if we consider the our function that is incomplete I function, we will be providing a general, or we can say generalized form of the integration. Again, Qureshi et al. Defined these three integrals which are very popular in the literature. And again, MacRoberts also defined these two integral. So these integrals will be going to use for our result. So here you can see, if I consider this particular integral along with this lower gamma function, we have considered this lower gamma function. So if we consider this one, then the final result will be given in terms of gamma functions, and those gamma function will be interpreted with the definition of the incomplete I function and again converted into the incomplete I function. So we can say this is the simple integration of this particular function and available in the special function. So beauty of these results are very simple, that they are integrating a special function and again converting into a special function. So these are the very important in the application part, because the integration of this particular function is providing another function which is again a special function. So you can see these are some few results. I'm going to skip those results because they are parallel to the nature. This is the same type of integration available with the upper case. This is another integration which is available with the lower type of incomplete I function, and again the result is given by this one. Further, if I consider the upper case, it will be providing this one. So again, you can see, if you recall, the lower and upper function having the property, if we get the decomposition of both of them, it will provides you the original function. So these results are having, every result associated with the incomplete function having beauty, that if we add all the results, they will be providing for the original function. So if you want to get the integration for incomplete complete I function, then you simply add both of them and get the result. These are few more integrals associated with this Qureshi. So I simply skipping those results. There are number of results associated with these incomplete I functions. Okay, now come to the another part of the talk. Here we consider the MSM fractional calculus operator, Marisev-Sagomeda operators. So if we recall, the Marisev and Sagomeda defined these generalized integration fractional integral operators, and they are very frequently used for the persons working in the area of special functions. So we are using here these integral operators as well as differentiation operators to get the image formulas for our newly defined function incomplete I functions. So these are the functions available already available in the literature. These are the fractional derivative operators, okay, and they are defined in terms of the fractional integral operator. Again, the function f1 is used, F3 is used in these operator, it is an apple function of this particular type. Okay, so these are few image formulas which are associated with the incomplete I functions, and they are available in the research papers. So the MSM operator of this lower integral, lower incomplete I function is given by this one. So again, I am saying the beauty of these results is that they are independently useful for the literature, as well as if we make a decomposition of all the results, both the results, it will provide you the result for the I function. Further, it is another result associated with the upper type of incomplete I function. Again, these are the another right hand. There are two types of fractional operator, right hand side and left hand side. So this is for the right hand side part. These are the fractional derivative formula for these two functions. I'm just skipping those results because they are familiar and similar in nature. Okay, so here you can see why we have considered this MSM fractional operator. If you understand, this particular fractional operator is the generalized version of the Sago operator, Riemann-Levelé, Erdős-Kober, Wiley, and many more fractional integral operator. So after substituting some parametric representation, if we put some particular values to the parameter, these fractional integral operator will converted automatically into the another fractional integral operator like Sago operator, Riemann-Levelé operator, Erdős-Kober operator, and many more. So using these results which are presented in the previous slides, we can easily get the number of results associated with the Riemann-Levelé, Sago, Erdős-Kober operators and incomplete I functions. Particularly, if we put x equal to 0, that means if we remove the incompleteness, if we put x equal to 0, these results will be automatically converted into the fractional calculus results associated with the I function. And they are well reported in the literature. The persons already given these results. So these are the particular case of our result. Okay, now we come to the application part, because it is the very important part associated with these incomplete functions. So if we go to the literature, then Fox H function and H bar functions, that is incomplete type of H and H bar functions, having number of applications in internal blood pressure equation. They have given some applications in this. Similarly, determination of Lambert law, and again impact of environmental pollution and growth, concept of biological population, fractional kinetic equations, and many more. So here you can see I have also provided some citations to those problems. So they are already available in the literature in which these incomplete functions having applications. Now we come to the applications of our function, that is incomplete I function. So we will come to the concept. If we mathematically see the concept of blood pressure, then the concept mathematically blood pressure in the, just a minute, blood vessel follows this particular relation. Okay, and if we convert these relation in terms of a differential equation, it will provided like this: dv by dp equal to tau. So with these two particular condition, now if we use the solution of this equation, it will be provided by this linear equation. Okay, now if we express this particular relation in terms of gamma, then we can write our result like this. Okay, we simply representing our result in terms of gamma. So now if gamma will be replaced with this function, now if we multiply and divide both the sides, left hand side as well as right hand side, to this particular factor, then obviously the left hand side and right hand side will convert it into the incomplete I function. So here you can see our blood pressure equation will converted having this incomplete function. So in this particular result, we have expressed the blood pressure equation involving the incomplete I function. However, the particular application of this particular result is not obtained yet. We will be trying to get the result. But initially, we have simply get the application of this function for representing the blood flow equation. Similarly, this is the another result associated with the lower incomplete function. Again, you can see the Lambert law, the similar type of differential equation is there. To get the solution of this equation, we make integration of this one. And again, if we represent this particular function in terms of gamma and then multiply or divide by this factor, so left hand side and right hand side will automatically convert it into the incomplete I function. So here you can see these are the two results associated with this incomplete I function. Okay, now come to the last part, which is very important. I have considered only few of the applications for this particular function. Now, using these newly defined incomplete function, one can easily get some fundamental properties including recurrence relation, transformations, formulas, expansions, orthogonal property, integral may be proper, improper, or whatever it is. We can also get some more generating functions associated with these two functions, maybe of linear and bilinear type, because as far as my knowledge, the work has not been done in this area with these two functions. Further, integral transformations, fractional calculus associated with these two functions and another special functions. We may also calculate some mathematical model involving incomplete I functions like kinetic equation or any other equation. Some computational part, may be graphical representation or graph, may be done with these two incomplete function. Probability and distribution area is still waiting for the work because the main application of these incomplete function is with the probability and distribution area only. So these are some future scope which we can done with these two incomplete I functions. Thank you very much for your patience and hearing me.
Thank you, Professor Purohit. Participant, if you have any doubt or question, please ask to us. Okay, one Sibu, Professor Sibu can ask you one question. Please, Sibu. Okay. Any query, question, participant? Okay.
Sir, if you permit, I would just like to congratulate Dr. S.D. Purohit. It's such a happy moment for a teacher to see someone who has presented, I don't know mathematics, but he has presented it so well. I really appreciate the presentation and the effort that he has made and wish you all the very best.
Thank you. Thank you very much, ma'am.
Okay. Thank you, Professor Purohit. Especially your talk is very informative, interesting, and especially for the I function. Okay, incomplete I function with the here applications, and it is also are very interesting. That is how you show here. It's really good sign. And this is also very informative for the participant when you go for the in the literature of I function. Now, Professor Purohit, could you suggest some book or literature here for the participant that you use here? Reference means in general.
Sir, in incomplete functions, there is no book available with the literature. But for H function and I functions, there are some books available with literature. If you remember that Houpold, Saxena, and Mathai,
Right.
The book is available with the H function,
H
And,
function, yes, yes, yeah.
yeah, and Goel book is available for the I function. So if we use those books, the results available in those book can be obtained in similar way for these incomplete functions.
Okay, right.
So
Very good.
I can say there are thousands of results available with H and H bar functions and I functions. So if we go parallel to those results, we will be getting few more results associated with these incomplete I function very easily, and they may have some number of applications. If you see, there are number of applications of these H functions available in astrophysics and mathematical modeling. So those
Mathematical physics
functions,
also.
yeah, mathematical physics. So those function may have some more applications